start off with a homework question on 313, number 6. 3.13, number 6. So here we're wanting to solve this here. Now again, whenever we're solving by factoring, the first thing we need to do is get the equation equal to 0. So we will subtract 5. So really, it doesn't matter if we need to move one thing, two things, three things. We need to get the equation equal to 0. Go on and grab a Chromebook. Yes. And now that we have this equal to 0, we can factor to solve.
In his ear. My mom's like, I can stop. And out this big old spider came. It's creepy. He's running in circles. I remember Phil because he was going to sit back.
Okay. Pull up Google Classroom. You'll need those. You'll need those too. So go and plug those in. Right here.
Okay, that was probably just you because your brain develops faster than everyone else's or something. Is that supposed to be racist? No, you guys are just like really, really smart.
There we go. Refresh. Oh, not what I meant to do. But yeah, you can do it full screen. Just follow along. Make sure to write everything down. All right. Sorry about that. Yeah. Too many spaces. So n plus 5, 2. So you should get that n equals -5 and n is -2. Okay. Other questions on the homework?
Wait, what number was that?
Number 6.
You do number 10 also.
Yeah.
I need a refresher.
10. So, all right, guys.
I got the gist of it. I just didn't finish.
Let's focus in here. So, we need to get this equation equal to 0. Now, there's two ways we can do it. One is going to be subtract 27b from both sides and add 18. Or we can subtract negative 10b squared from both sides, which will tell us 0 is equal to negative 10b squared plus 27b minus 18. So I would put it in terms of decreasing power, our squared term first power constant. So it's kind of easier to arrange this here. Greatest common factor is going to be next. So we're trying to look for a term that goes, number that goes into all three terms. Well, there isn't one, but we would like that b squared to be positive, not negative. So we can factor that negative out. Now, it's not wrong to leave it as a negative, but if we do, when we find the factors of 10b squared, we actually have to find the negative. One of them is going to end up being negative. One of them is going to end up being positive. Now, if we take the negative out, we don't have to worry about that there. Now we move on to our two sets of parentheses with three spaces. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Well, here the third term is positive, so the signs are the same and match the sign of the middle term. Negative and negative. Now we need to find the factors of the first and third term. Well, 10b squared, we would have b and b. Factors of 10 are 1 and 10 or 2 and 5. We can start with 2 and 5. We go on and just plug those in. Factors of the third term, factors of 18, 1 and 18, 2 and 9, 3 and 6. Which one of these do we want to try first? 2 and 9. So we'll have to put the 9 with the 2b and the 2 with the 5b, because can't put 2b and 2 together. They would have a greatest common factor, and there's not one to begin with, so we can't have one here. Now when we check this here, 2b times negative 2 is negative 4b. Negative 9 times 5 is negative 45b, negative 47b. So we can't have the other arrangement with 9 and 2, but we can try 3 and 6. Now we've got to put the 6 with the 5b and the 3 with the 2b, because 6 and 2b would have a greatest common factor of 2. Since there's not one to begin with, there can't be one in either parentheses. Now if we check this here, 2b times negative 6 is negative 12b. Negative 3 times 5b is negative 15b, and this would be negative 27b. Is that the middle term we wanted? Yes. Now, whenever we have two or more things multiply together to equal 0, one of them must be 0. Either 2b minus 3 is 0, or 5b minus 6 is 0. Now, with our 2b minus 3, first thing we can do is add 3 to both sides, showing me 2b is equal to 3. Then we can divide both sides by 2, so b is equal to 3/2. Our other one, we would add 6 first, showing me 5b is equal to 6. Divide both sides by 5, telling me b is equal to 6/5. Now, if they would reduce, we would reduce them, but the only way these would reduce is if they had a greatest common factor or a common factor. They shouldn't, but if they did, then we would reduce. Answer those questions. We're ready for today's. I've heard from some today that they found it very challenging. Yes. Oh, it was that, yeah. Yeah. So, again, I don't normally like calling things easy, not because that isn't the case, but there's some things that some find easy and others don't. And if they don't find it easy, it seems less that they find it that they don't quite understand it or don't find it challenging. It's more that something with themselves. So I don't normally like calling things easy, but this does follow a pattern. Difference of perfect squares. If it is a difference of perfect squares, the reason we define it as such is our two terms that are being subtracted are perfect squares. We can rewrite them as something times itself. That's what a perfect square is. And they're a difference because they're being subtracted. So the difference of perfect squares is two terms that are being subtracted, and both of them are perfect squares. And if we do have that, a squared minus b squared is equal to a plus b times a minus b. So if we look at the example they gave us, x squared minus 9, well, x squared is really x times x. X squared is a perfect square. X and x times itself. 9 is a perfect square because it is 3 times 3. Our a in this case is x. B is 3, giving us x plus 3 times x minus 3. Well, let's look at an example of this here. X squared minus 25. It is a difference. We have two things being subtracted. X squared is a perfect square. What times itself is x squared? X. So our a in this case is x. What times itself is 25? 5. So our a squared minus b squared is equal to a plus b times a minus b. So a is what? X. So we'd have x plus b. So x plus 5. So a minus b, it would be x minus 5. We're ready for the next step. Now, that's the same answer. Because all we did was flip it. Because we can multiply any two or more things in any order. Order doesn't matter. I just have to have both. I don't need both of these. I just need one of them. Either x plus 5 times x minus 5 or x minus 5 times x plus 5. Same answer, just written in a different order. Questions on this here? We ready for the next one? 4z squared minus 1. So it is a difference of two terms, yes? The difference of perfect squares is only two terms, and they are indeed being subtracted, yes? So we need to determine if the first one, 4z squared, is a perfect square. Because what times itself would be 4z squared? Or what times itself is 4? 2. And what times itself is z squared is z. So 2z squared would be our, 2z would be our a. Now we need to figure out what times itself is 1. 1. So then we can plug it in. So our first one is a plus b. So this would be 2z plus 1 times 2z minus 1. And that's it. That's the nice part about a difference of perfect squares, is that it's going to follow this pattern every single time. Questions on this here? Are you ready for the next one? X squared minus 64. We do have a difference of two terms, because again, difference of perfect squares will only have two. X squared minus 64 is x squared a perfect square. Yeah, it'd be what? X times x, or x squared. And what times itself is 64. Hey. So a is x, b is 8. So we could say a plus b, so that would be x plus 8 times a minus b, which would be x minus 8. Questions on this here? We ready for the next one? X squared minus 36. So what times itself is x squared? X. What times itself is 36? So what we've done the last few steps, putting it in parentheses squares, is just another way to remind ourselves what is A, what is B. If we can see it, we can plug it in. So if writing it out, going from here to x squared minus 6 squared, and then to factored forms help, do it. If it doesn't make a difference, I want to just factor it. Up to y'all. Questions on this here? We feel good about these here. Well, this one looks a little different, yes? What is our A? 100. So what times itself is 100? And then the second one would be m squared, yes? So our first one would be what? 10 plus m, and the other would be 10. Now, it's very tempting to want to just flip it and say m squared minus 100, but those would be two separate statements. And it is possible to do it, but we have to factor out a negative to get there. So it's a little bit easier just to leave it as 10 plus m and 10 minus m. Does that make sense? Okay. 3n squared, or not 3, 9n squared minus 16. Well, I kind of gave it away. Because 9n squared would be what? 3n and 3n plus minus. What times itself is 16? 4. So we'd have 4 and 4. Any questions on any of this so far? Okay. What times itself is 16h squared? Well, 16 would be 4 and 4. H squared would be. And what times itself is 49? 7 and 7. Questions on this so far? We ready for the next one? 25b squared minus 36. So we do have a difference. We have two terms. What times itself would be 25b squared? 5b, 5b. And what times itself is 36? So 5b plus 6, 5b minus 6. Now, if it does look like it is in the form of a difference of perfect squares, and both, one or normally it'd be both terms aren't perfect squares, they're just off by a little bit, see if there's a greatest common factor. Because it's not uncommon for them to have a greatest common factor of 2, that once we factor it out, what we're left with is perfect squares, and we can factor from there. So, I want to do one more. I want to do this one here, 64x squared minus 144y squared. It's not in your notes, I'm going to go on and add it in. Because this is the first one where we had variables show up twice, yes? Now, is there a greatest common factor between these two terms? I'm trying to remember. Let's see here. 8 does work. but there is one bigger. Actually, $16. 16 will go into both terms. We could have listed all the factors out and seen what was the biggest number that goes into both, or worked it out. Now, 16 is the greatest common factor. We can factor it out and go from there. Now, on the other hand, let's say we didn't notice it. Is 64 a perfect square? Is 144 a perfect square? Okay. Plus, what times itself is 64? 8. And what times itself is x squared? X, yeah. And then 144 would be 12. And we'd have y, yes? We feel good about this so far, yes? Now, if it said to factor it, that is factored. It is not factored completely. Is there a like term in our first set of parentheses? There's a greatest common factor of 4. So we can still factor a 4 out of 8x squared plus 12y, which would give us a 4, but the 8x is going to become 2x. Our 12y is going to become 3y, because we're just dividing both terms by 4. We understand how we got there. Well, if I could do it out of that one, I can also do it out of our second one, which would give us another factor of 4 multiple of 4 out front. And if we do divide it out of both terms, 8x becomes 2x, 12y becomes 3y. So this here is factored. That's completely factored. So 8x plus 12y times 8x minus 12y is factored. It is factored. But if they're asking for it to be factored completely, we needed a 16 times 2x plus 3y times 2x minus 3y. Can we kind of see the difference between those two? But the reason that this worked and we could factor it without removing that is partly because the greatest common factor is 16, yes? Is that a perfect square? Yeah, so it still works because it is a perfect square. If that greatest common factor is not a perfect square, so 2, 3, 5, 7, we have to factor it out before it'll work. Questions on this here? We ready for the last part of this? Use the special product pattern to evaluate the expression 54 squared minus 48 squared. Well, the special product pattern is what we've been using this entire lesson. A squared minus b squared is equal to a plus b times a minus b. Well, a in our case is 54. B in our case is 48. So if we use this pattern here, we can do 54 plus 48 times 54 minus 48. Well, the first thing we would need to do is add 54 and 48. $54 plus 48 is 102. 54 minus 48 is 6. Now we just need to multiply these together. Yeah.
I was like,
They're all numbers. We can just plug this in. Because the next one, questions on this here. Yeah, 612.
because I just put it in the calculator originally.
68 squared minus 62 squared. 780. Yeah, I mean, they're straight numbers. There's nothing stopping us from just plugging these in. The only reason this is nice is if we didn't have a calculator and we're trying to figure this out, we could figure it out quickly. Add them, subtract them, and multiply those two numbers together. So that's it.